Hello, everyone. Today we are just going to get through the second part of 7.4. Yesterday we were talking about how to solve these different polynomials that were already in factored form. Today we're really just going to get into how do you actually do that yourself? How do you go through and factor these polynomials? You want to make sure that you get this assignment done. I'm still giving you the Friday to turn it in, even though technically Friday is not really a school day. You can't go to homework help. They're not going to open the school up like they normally do, but I'll give you the day to turn everything in just like you normally have on Friday. I really would advise to get everything from this week done. You really don't want to spend either the long weekend or next week catching up on all this stuff. You want to be able to enjoy and relax a little bit. So just make sure you get it done. Shoot me an email if you get stuck on anything. And I'm going to go ahead and get started here. So this first section, it just says factor. Okay, there's really two things I can ask you to do. I can ask you just to factor, and you'll notice that none of these have equal signs, so I really couldn't solve them even if I wanted to because they're not equal to anything. And then when you have full equations, so here you have actual, equal to 0 or equal to something else, then you can actually solve just like we did yesterday when we were able to find those different roots. When we said, okay, x is equal to this, y is equal to this, that's what I'm talking about when I say solve. So when I just say to factor, you're not going to get x equals this. You're not going to get y equals that because it's not equal to anything. So there's really nothing to solve for. You're just factoring. So let's start with the factoring. We have right here, let's start with number 13 because I think that's the easiest one. You've got this 6x squared. Zoom way in. We've got 6x squared plus 3x. So we're thinking, I want this in factored form. Right? Factored form usually means I've either got you change the drawing. I've got two binomials, so something like x plus y, something like that. Or I have something on the outside multiplying some binomial. Pretty much all the factoring that we're going to do in this chapter, at least, or in this section, all of that's going to be, let me just take one thing out and put it on the outside. That's how I like to think of it. Think of it almost like reverse distributive property. Okay? We're trying to think there's something here. Instead of multiplying everything inside the parentheses, you're thinking, what can I divide both of these by and have sitting on the outside of my parentheses? It's kind of the reverse order of distributive property. Okay, so think about you've got 6x squared, you've got 3x. What's something that can divide evenly into 6x squared and 3x? I like to think about the number first. So, what divides into 6 and 3? 3. So I'm dividing each one by 3. Then I like to think about the variable part. All right, so you're thinking, what divides into x squared and x? Well, it's not x squared. I can't go any higher exponent than the lowest exponent, if that makes sense. All right, I can't do x squared because this only has x. It's just x to the first power, basically. So I'm thinking I can take an x out of each of these terms. I can say, all right, I'm dividing both of these by an x. Okay, so think about what you'd get for each one of those. Okay, the 3x, that's going to go to the outside of your parentheses. You're basically taking it out of each one and putting it on the outside. Here, what are we going to be left with? 6 divided by 3, I get 2. X squared divided by x. Go back and think about your exponent rules if you're stuck on this. X squared divided by x, well, it's kind of x to the first power, right? And when you divide those exponents, you're subtracting your exponents. So you're thinking, 2 minus 1 is just 1. So I'm left with just an x here. You could think, x over 1 if you wanted to, but we know that's the same thing as x, right? Then, 3x divided by 3x. I know anything divided by itself is just 1, right? That's all we need to do. This is my final answer here. I know this process is a little complicated because we're used to doing the opposite, right? We're used to seeing, okay, cool, 3x times 2x plus 1. I'm going to distribute that. I'm going to multiply each, okay? 3x times 2x, that is 6x squared. And then 3x times 1, I get 3x. All right, there's my answer. You're used to going that direction. Now we're we're reverse engineering it a little bit. So it's a bit tricky the first couple times. Okay, just stick with it. If it doesn't make sense right at first, just keep trying. Let's do at least one more just like this. Let's do 16. 16 looks a little tricky. So I've got 7, let's say 7z to the 7th power and 2z to the 6th power. Okay, getting kind of crazy with these exponents here. Again, I'm always thinking about, I'm going to be left with something from each of these terms, and then something's going to go on the outside here. Whatever I divide each of these by is going to go to the outside of my parentheses. So I want to think, okay, what can I divide from each one of these? If I think about my numbers, okay, what divides into 7 and 2? Well, nothing, right? Nothing divides evenly, at least. So I can't take out anything from the actual coefficient. That's going to just stay the same. But I can take out a z. And in fact, you can take out whatever the smallest exponent is. Okay, so I don't just have to stick with the z, because I could divide just a z, but I could go as far as that smallest exponent. If I have a z to the 6th, I can divide out a z to the 6th here from both of these terms. Right? So the process here, whatever you divide out, you can slap that on the outside, z to the 6th power. Then think about what you're left with. Okay, z to the 7th power minus z to the 6th power. That's just going to be 7's going to stay the same. It's going to stay on top there. And then z to the 7th minus z to the 6th. That's just z to the 1st, which is just z. Then over here, okay, z to the 6th. Well, I'm dividing here by z to the 6th, so the 2 is going to be left, but the entire z is going to get divided out there. They're basically canceling out. All right, so I'm left here. I've got that z to the 6th on the outside, then 7z plus 2 on the inside. If you ever want to check your answer, make sure it makes sense, you can distribute it back out. Okay, does that make sense? I get 7z to the 7th, okay, times 2, I get plus 2z to the 6th. When you get the same thing, you know, okay, that works. You might want to do that, especially the first couple times you try, because again, this is a little bit different than what you normally do. It's kind of the opposite of what you normally do. Alrighty, let's go on. This is all factoring. Then this next section that we see here, you essentially want to factor and then use that factored form to solve your equation. So again, this is a little bit new. It's a little bit tricky, but that's okay. Let's think about, trying to think of a easier one. Let's do 21. I'll probably do at least 2 of these. Right. So I've got 4z squared plus 52z equals 0. And here's what people start to do. They start to totally lose their minds, and they try and combine these two things, even though they're not like terms. They try and do all kinds of crazy stuff to try and solve out this polynomial. The stuff you have in your normal bag of tricks from when we were way at the start of the year solving these normal equations, they're not going to work with these types of polynomials. You've got to do this totally new process. So first you want to start by factoring, and then we're going to do just like we did yesterday. We're going to use that factored form, set each little piece equal to 0, and we're done. All right, so okay, 21. We're going to go ahead here. We're going to think, what can I divide from each one of these? Okay, each one of those little terms here. I'm going to say, well, I can divide out a 4 from each one of these. Okay, 4 divides into 4 evenly. And then into 52 as well. I had to check in a calculator. That's a little embarrassing. Okay. Then I've got my variables. I'm thinking, what can I divide evenly into both? If you're not sure with the variable part, I think that's the toughest part for most people. You want to think, okay, what's the lowest exponent that I have? Hey, you've got just a plain z, so you can think of that as 1. Well, that I can divide out of everything. Okay, so z and z. So I'm going to divide both of these by 4z. Okay, I'm taking out 4z, so that goes on the outside of my parentheses. And then, okay, 4z squared divided by 4z. Well, my 4's are just going to straight up cancel out. And then z squared divided by z, I'm just left with one more z. Then that 52 divided by 4, I know that's 13 because I just plugged it in my calculator. And the z's cancel out. Okay, z divided by z just cancels. So I get this 4z times z plus 13. Those are my two factors. Those are the two things that multiply together, and I end up with 0. So I really want to make sure that I remember from yesterday, okay, 2 different things multiply to 0. I know that means one or the other of them equals 0. I'm going to set each little chunk equal to 0. So 4z equals 0, z plus 13 equals 0. I'm going to divide here by 4. I get z equals 0. Anything 0 divided by anything is just going to be 0. Then over here, plus 13, so I'm going to subtract 13. I get z equal to negative 13. All right, so most of these you're probably going to end up, I think you're going to end up with 2 answers for all of these. So again, z is equal to 0 or z is equal to negative 13. Right? I know this might be a little tricky. I really want to spend some time on Tuesday making sure you understand this. So if you have any questions, make sure you can shoot me an email either on the Friday, on the Tuesday, anytime that you work on this. And I hope you have a great long weekend. See you guys later.